I want to tell you a story about a bug because it's a story that I think highlights the interesting levels of abstraction and layers that we work at. So we're going back a little way here. This is probably 2008, 2009, and the system I was working on at the time, we had a bunch of redirects in there. So this is in the days before ASP.NET MVC. That was just around the corner. So we were working in classic ASP, and we were using an old school technique where to be able to kind of do arbitrary URLs with a dynamic application, what you had to do is you had to intercept the 404 not found. And so when you got a page not found, you would run a custom page which said, well, do we think we know what they were asking for? And you would parse the URL, you'd get that out of the request information. And that would then allow you to say, okay, well, this page doesn't exist, but it's a request for this particular piece of information, so you could bring that back. And that's how we did, nice clean URLs and gave ourselves some kind of routing capability before frameworks did this. And we had one page that you couldn't use it in Firefox. And we're sort of struggling to think this is weird. It works in, works in Chrome, it works in Internet Explorer, which we were still supporting back in the day. Firefox didn't like it, and it worked everywhere else. It was just this one page, and so we started, okay, what are the variables here? Do other pages work? Yes, of course they do. You start kind of figuring out in your head what is unique about this particular situation. And so we tried a couple of other pages, they worked. We figured out that there was a post. It was an HTTP post. It was a form request, and Firefox couldn't post forms that were being bounced through this HTTP 404 error handler. Now, other browsers worked. So it wasn't a fundamental problem with the approach. There was something unusual about Firefox with it. So we started digging. Now, the first thing that we did was we put in a thing called Charles, which is a network proxy that allows you to capture all your HTTP traffic. So you can see exactly what's being requested and responded. So we put it in Charles. We set Firefox to go through a proxy. Problem goes away. It's fixed. Like, if you're going through Charles, it works. So we're thinking, okay, this is really weird. Now, at this point, the theory is that Charles is actually rewriting the traffic. So all the requests that are going through, maybe it's cleaning something up. Maybe there's something, there's a flaw or a vulnerability, just something weird in the combination of Firefox and Internet Information Server, and putting Charles in the middle is cleaning the thing up. So we thought, what do we do next? And this is where you start kind of chipping away the layers of abstraction. Because you got the, browsers up here. Charles gives you visibility on the network traffic at a kind of browser level. Charles is a web proxy. But then the next level below that, what you want to do is look at the raw network traffic, the actual TCP streams. And the tool that we use to do that is it used to be called Ethereal, which is a brilliant name for a piece of software that does Ethernet stuff. And now I think it's called Wireshark, because there was, I believe, a fight between the people who owned the name and the people who managed the code. So anyway, we installed this thing and got that to sniff all the network traffic and started looking at it. And what we discovered, it's one of those days when you dive way deeper into the internals of TCP/IP networking than you ever thought you were going to, was that when Firefox submitted the forms to this thing, IIS was discarding the first packet, only the second packet. So we're talking about 1,024 bytes, 1K. First packet was getting discarded, and only subsequent packets were making it into the handler. And something about the way Firefox constructed that request meant that IIS was discarding it. So we, sat around, scratched our heads, like, how do we fix this thing? We could wait for Firefox to fix it, but we have customers right now who want this thing to work. We have no idea how to fix it in IIS. And what we came up with eventually, and I think this code might still be out there in the wild somewhere, is at the top of that form, we put 1,024 X's. We just put a hidden input field with a comment above it saying, we need to pad the form to 1K, so the stuff we actually need is then in the second of the network frames that makes it into IIS. And so we put in XXXX, literally 1,024 of these things in a hidden form field, and we tested it, and it worked. And, on the one hand, that's disgusting. That's a horrible, horrible hack. But on the other hand, it was very easy to see. Like, you saw this thing in the code, we got new people on the team, they'd look at it and they'd be like, what? And they'd look at the comment, because, a big string of X's, that's like a big red flag. Look at the string of comments in there and they'd be like, oh, really? That's weird. And, sometimes people would take it out and try it and they'd be like, oh yeah, wow, I see why you did this. So But yeah, that was one of those interesting days when you have to kind of dig 2 or 3 levels deeper than the level where you're accustomed to working. And any day you have to run a TCP network trace to figure out why a web page doesn't work. It's definitely a day that you're going to write up as a learning experience. And so yeah, that was the problem. That's how we went around chipping away the layers of abstraction. And the solution we eventually shipped was a big bag of X's to pad everything and flow it over into the second frame. So yeah, there you go, a little bit of on-the-job knowledge sharing. Thanks for listening, folks. Take it easy. See you online.